All right, guys, so today we're looking at lesson 1-3, which is on properties of parabolas. Our essential question for this lesson is to describe 3 different parts of a parabola. I want to stress the fact that I'm asking for you to describe, so make sure that you give me a thorough description of what it is you've chosen to talk about the parabolas. All right, so for our vocabulary, our first term is the word parabola. And a parabola is the shape of a quadratic graph. And I'm just going to put in parentheses here, it's that U shape that we saw in our last lesson. All right, now for the vocab, I'm actually going to pull a picture that I've already printed of a parabola, just so that it's a nicer picture and I'm not trying to sketch it on lined paper. I've included this picture in your printables if you were able to print those out, but it should look like this. So go ahead and glue that down to your paper if you were able to print that. We're going to mark this picture up with all the different parts of a parabola. Now make sure you give yourself enough room. Make sure you've drawn, if you weren't able to print, make sure you've drawn your parabola large enough so that you can draw arrows and also include definitions on this picture. Now, the program I use to sketch out my parabolas doesn't allow me to put arrows at the ends. But the thing I want you to look for most, like if we're talking about domain and range and we're looking for those endpoints, if there is an endpoint, it will actually have a dot or a circle at the very end of the graph. Otherwise, it's a continuous graph. It's an infinite graph. So the arrows are going to be implied unless there are dots or circles at the end of your graph. So the first thing I want to identify is the very bottom of our graph right here. Now this point down here is what we call the vertex. And the vertex, I'm just going to include the definition directly under this, is the highest or lowest. And underneath, I'm going to put in parentheses, maximum and minimum. The highest or lowest point on a parabola. Okay, so this is obviously the lowest point on our parabola because this is the point where our parabola turns back around. So this is actually the minimum of this graph. The next term I want to talk about is called the axis of symmetry. The axis of symmetry is an imaginary line that goes directly through our vertex. Now, if you have different color pens, feel free to use them while we mark up this picture. All right, so the axis of symmetry is the imaginary line that goes through the vertex and divides the parabola in half. So basically, if we were to take this piece of paper and fold it along the axis of symmetry, you'd have this side of the parabola lay directly on top of the other side of the parabola. So it's splitting it into two congruent pieces. Now, before I move on any further, I want to identify specifically both of the things we've talked about so far. So we talked about the vertex, and notice that the vertex is a point on our graph. I'm going to color code that one as well. So I'm going to make this one pink color. So this is our vertex. And the coordinates of this point are the coordinates 3, -4. So anytime you're asked to identify the vertex will always be a point on your graph. Now, if you notice, the axis of symmetry is not a point, but rather is a line. And when we're writing the equation of a line, it's either going to start with x equals or y equals. Now, this is where it gets a little bit tricky. I know that vertical and horizontal lines can be a little bit tricky sometimes, but how I want you to think about it is which axis is my line crossing and at what value is it crossing? So this line right here is crossing the x-axis at +3. So the equation of this line is x equals 3. Now, if you notice in our vertex, the x value of the vertex is 3. And that's not a coincidence. It's because the line, the axis of symmetry, goes through our vertex at the x value. So that's always going to happen. But you have to remember that a vertex is a point, therefore we write it as an ordered pair, and the axis of symmetry is a line, therefore we write it as the equation of a line. The next thing I want to talk about is the Y-intercept. The Y-intercept. Now, we have identified the Y-intercept before, and we know that the Y-intercept is where our graph intersects the Y-axis. So that's going to be this point right here. And that, again, is a point on our graph. So we need to identify it as so. And the coordinates of that point are 0, 5. So just to define Y-intercept, the point where the graph crosses the Y-axis. And that leads me to our x-intercepts. Now, I know we've identified the x-intercepts on our linear graphs last week, but notice now on the quadratic graph, because it makes that U shape, it actually intersects our graph in 2 separate places. So we're actually going to identify 2 x-intercepts. This point here is where our graph intersects the x-axis, and this point here is also where our graph intersects the x-axis. Now, these are points on our graph as well, so we need to identify them as ordered pairs as well. This point right here, the point 1, 0, and this point right here, the 0.5, 0. These are the point, and I'm going to put S in parentheses because sometimes there might be only one, but the point or points where the graph crosses the x-axis. So these are all the different pieces of the parabola so far. Now there are a couple more things I'm going to add on as we go through our GPs for today, but this is all we have for our vocabulary page.